Hello, welcome back to Chapter 8, Section 6, where we're talking about radical expressions. And in a couple of videos, we're going to introduce some rational exponents. What does that mean? We'll get there. All right, so we are going to talk about properties of radicals and roots. The radical is actually the symbol, okay? However, the idea means like the root, the square root, the cube root, the fourth root. But I use them interchangeably. Please call me out if I do something that's kind of weird. All right, we're going to talk about the properties of these, and these properties allow us to simplify. They allow us to, like everything else we do in Simplify, means that we're going to take a complicated math example and try to make it as easy as possible. What we're really doing is we're learning skills that are going to allow us to solve equations eventually and do other things that even go beyond solving equations. So the main idea in this example is that we're just going to be learning some skills. It's like going to shop class and learning how to like work the bandsaw or how to work like a sander or something like that. You're just learning tools. All right, so keep that in mind. And also please keep in mind, I keep saying this, algebra is a language and no one is born understanding that language, or any language for that matter. No one is born understanding the language of algebra. It's not genetic. So most of the time when people are struggling with something, they're struggling because of the way it's written. So that's my job. My job is to say, here's why we write it this way, or sometimes I don't even know why. I guess why was a bad way of saying it. But here's what it means, and this is how we use it. So that's what I'm going to be doing in this video. So we're going to talk about properties of roots. One thing is that if you have, I don't know why they do it this way, I'm going to go backwards. If you have the nth root of a number, and n just stands for like, could be the square root, so n equals the hidden 2, cube root, fourth root, fifth root, whatever. But if I have the nth root of a number, whatever that number is, I'm going to multiply by the nth root of another number. So the index of the radicals, both of these are the same. Both of them are nth root. I can combine, it's not a real good word to use, but it kind of works. I can mush them together, and I end up with the nth root of whatever a times b is. That's very, very useful. That's called the product property. So in this example, going this direction, which to me seems like it'd be backwards, but that's okay. If I take the cube root of 16, now I don't know what the cube root of 16 is, but I do know that 16 can be factored into 8 times 2. Now why 8 times 2? Because 8 is 2 to the third power. So I separated this going the other way. I separated this by the cube root of 2 to the third power. This actually means cube root of 8 is actually the cube root of 2 to the third power. And that equals 2. Remember, these are inverses of each other. They undo each other. All right? So what we have here is if I can bring out this much, I've got 2 times whatever this is. Now, I don't know what the cube root of 8 is. It's going to be irrational, kind of like it's not the same as square root of 2, but it's irrational, like the square root of 2 is irrational, which means it's going to be a decimal that continues forever. And for our purposes, we just leave it like that. We don't try it. We're not going to be estimating unless the directions, and I don't think there's any problems in this section that do that, but unless the directions specifically say estimate, maybe the application problem, okay? But unless the directions specifically say estimate, we're going to leave everything in radical form. Now, along with the product property, we have the quotient property. And again, I'm going to show you this over here. So if I've got the nth root of something divided by the nth root of something, then I can combine them by the nth root of whatever the a divided by b is. So I can put it under one radical. And going the other way, just like this example, I can separate it under two different radicals. One in the numerator, one in the denominator. So if I start out with square root of 25 over 16, that becomes square root of 25 over square root of 16, which of course simplifies to 5 over 4. So one of the keys to this, like this example, is to try to find out what's under the radical and can I write it in a form where I have an exponent that matches up with that index. I'm going to say that again. Can I write a number that's already under the radical in a form where the exponent is the same as the index of the radical? So like I wrote 16 into 8 times 2 because I knew 8 was 2 to the third power. The form of 8 that uses an exponent is 2 to the third power, and that 3 exponent is the same as that index of the radical. So let's look at this example and see if this is going to explain what I just said. Let's start off with the first one. So I get 27x to the 6th power, and I want to find the third root of that. That's asking what number times itself again equals 27x to the 6th power. So let's start looking for ways to write this using the exponent 3. Well, 27 is nice because 27 is 3 to the third power. X to the 6th power, if I remember my exponent rules, that's the same as x to the third power times x to the third power, because my exponent rules say that when I multiply and I have the same base, I add the exponents. All right, so now I'm going to take the third root of all of that, and this ends up being the third root of 3 cubed times the third root of x cubed times the third root of the other x cubed. And this ends up being 3 times x. And of course we would write that 3x squared. Now, I'm going to just mention something and we're going to explore it in the rest of this chapter. Notice that if I had left this x to the 6, 6 divided by 3 equals the 2 that I ended up with there. I want you to keep that in mind. I'm going to do the next problem. The fourth root of 16 times x to the fourth. Well, 16 is 2 to the fourth. 2 times 2 times 2 times 2 is 16. And I'm going to take the fourth root of that. And this is just x to the fourth, so I'm going to do the fourth root of x to the fourth. And this just gives me 2x. Now you can go back and check this again. If I go backwards, I would say 2x to the fourth power. That becomes 2 times 2 times 2 times 2, which is 16, and x to the fourth power would be x to the fourth power. So you can check it by reversing it, just like we check a lot of things, by reversing it and seeing if you got what you originally started out with. Excuse me. Okay, so pause the video for that if you want to look over that again. I will be doing more examples like this when I do the guided practice problems video that is going to be coming up later if you're watching them all in order. Because the next two do that, but there's an extra twist at the end, and it's that extra twist that I'll probably have to mention live in class a couple times. But it's the same idea. I'm going to separate this. In the numerator, I've got x to the third, so I'm going to take the cube root of x to the third. So that's just like that one. That's going to end up simplifying to just x. In the denominator, I might have to switch my marker. I've got the cube root of 7, and that becomes an issue. Why is that an issue? Because unlike the previous two problems and the top here, I don't know what the cube root of 7 is. So this becomes the cube root of x cubed is just x, and this is divided by whatever the cube root of 7 is. So it's asking what times what times what equals 7. That is an irrational number, and that means that there is no way that I'm ever going to write it. It's a decimal that goes forever. So there's no way that I can actually accurately write it. whenever you see something like it, like, well, sorry. I was going to see if I can grab my calculator and show you, but we'll save that for later. I'm getting ahead of myself. But the cube root of 7 is going to be irrational. So unless it says estimate it, just leave it cube root of 7. But here's the problem. The rule is I can't leave irrational numbers in the denominator. What to do, what to do, what to do. All right, so I know that 7 times 7 times 7 equals 49 times 7, which is 343. All right, but now check this out. If I break this into two parts, and then if I take the cube root of 243, so the cube root, sorry, 343, then that's going to give me my 7, okay? So I can get a rational number here in the denominator if I multiply by something. This is called rationalizing the denominator. And what I have to do, I'm going to write the cube root of 7, except this time it's not just, now that's just 2 of them, but I need all 3 of them. So I'm going to have that cube root of 7 squared. Now, just look at this part right here. 7 times 7 squared is going to give me 7 to the 3rd power. The cube root of 7 to the 3rd power is going to be 7. So here in the denominator, I just get 7. And 7, God bless his heart, is rational. So that's good. That's this. Doesn't look like it at all. Okay. The numerator can be irrational. That's perfectly okay. So in the numerator, I get x times the cube root of 49. I'll go ahead and say 7 squared equals 49. Let's look at this problem. While you're thinking about that one, and it's still kind of like simmering a little bit, let's do this one, and then we can compare and contrast. So now I've got the 4th root. I want to break these things into powers of 4. X to the 8th power is x to the 4th power times x to the 4th power. I just gave myself some space because I'm going to draw more in there. And if I take the cube root, 4th root, correction, 4th root of both, then I'm just going to get x times x. In the denominator, I'm going to take the 4th root of 3. So I broke everything under the radical. If I could, like the x to the 8th power, I broke it into powers of 4, which that was nice. I was able to do that. The 4th root of x to the 4th power is just x. The 4th root of x to the 4th power, I'm just repeating myself, is x. This is x times x, so I get x to the 2nd power. And I'd like to point this out too, just a little bit of foreshadowing. Think about what 8 divided by 4 is. Okay, we'll come back to that. Now the 4th root of 3 is asking what number times itself again, times itself again. 4 of them equals 3. Again, it's irrational. All right, so I have to do something with it. I have so far the 4th root of 3. And if I think of this, I think 3 times 3 times 3 times 3. That's going to give me 3 to the 4th power. This is just what I'm thinking, so you can see what I'm thinking. So I have one of them already. How many more do I need? I need 3 to get to that 4th power. So I'm going to multiply by the 4th root of 3, 1, 2, 3, to the 3rd power. Now, 3 times 3 to the 3rd power, that 3 times the other 3 gives me 3 to the 4th power. And the 4th root is going to be 3. The top, it's going to be fine. I'm going to write it right here. X to the 2nd power times the 4th root of, I was going to write 3 to the 3rd power, but that's actually 27. So I'll squeeze that in. And then, of course, this is just going to be divided by 3. Now, I know a lot of times we look at these and we say, hey, I see a 49 here. 49 divided by... No, that's not it. That's not 49. That's the cube root of 49. Those are different. That's not 27. That's the fourth root of 27. Those things are different. Okay, so don't try to reduce this. As a matter of fact, I purposely, if you did try to reduce it, you would end up back here. So the whole purpose of this is to, and I'm going to trademark this word, to unreduce the fraction so that we can get the denominator rational. That's the whole point. All right, we got one more here. Unlike the other ones, this is going to be multiplying. So what am I going to do? Well, I noticed that I've got cube root here and cube root here. I'm going to use my property and do the cube root of x to the 7th power times x to the 2nd power. That's the cube root of x to the 9th power. I'm going to run out of room if I do it this way, so I'm going to go over here. That is x to the 3rd, cube root of that, times cube root of x to the 3rd, times cube root of x to the 3rd. 3 plus 3 plus 3 equals 9. So I was able to rewrite this x to the 9th power as the cube root of, as x to the 3rd power, x to the 3rd power, x to the 3rd power. And then I took the cube root of each of those. This ends up being x times x times x, which gives me x to the 3rd power. And I'd like to point this out one more time as we get ready for our next video. 9 divided by 3 equals 3. I wonder if there's a pattern there with that. All right, we'll see you in the next video.